All right, welcome everybody, week 14, day 3. So the most important thing to talk about is your GE Capstone essay has been posted. It'll be due in 2 Mondays from now. And it could be on any of the big topics that we've talked about in this class. You must demonstrate to me knowledge of each of the different main ways of arguing. And that'll be our topic for today. In addition, we'll do a little bit of set theory. So, set theory, as you probably saw from the midterm review, if you did that, which hopefully you did, it's a really important thing, and I like asking questions on it because it is that important. So let's do a couple examples of those. So let's say set A is equal to it's a horrible curly brace. Say set A is equal to, all right, better. The numbers from 1 to 10. It's a nice looking curly brace. B is equal to the numbers of 8 through 20. What is the size of A intersect B? This would be a standard, pretty easy midterm question. Okay. A is the set of numbers from 1 to 10, integers. B is the set of integers from 8 to 20. What is the size of the intersection of A and B? Or intersection means we are creating a new set. Whenever you do intersection between one set and another set, you get another set. So intersection provides a new set, and that set is made of everyone in common. In other words, numbers that appear in both A and B. So it's going to be 8, 9, and 10. Right, so the intersection of A and B is 8, 9, and 10. So yeah, the size of A and B is 3. Okay. So the size of the intersection of A intersect B is 3. Because this creates a set whose members are ones that appear in both A and B, and that's 8, 9, and 10. Now if I were to play an Uno reverse on this and turn this into union, what's the answer now? Yeah, so with union, you get a new set whose elements are either in B or in A or both. You don't add duplicates to it. So this the return set here would be simply 1 to 20, which is going to be 20. The size of the set is 20. Okay. So what is okay, so far so good. Let's do one more along those same lines. Let's do A is equal to 1 through 5, and B is equal to 10 through 20. So what is the size of the intersection? How many elements are both in A and B? Garcia is going with null set. Yeah, but the null set's not the size. The set returned is null set. Very good. The set returned is null set, but the size of the null set is 0. That's the question. How many elements are in common between A and B? Okay. That are in both A and B. Okay. So let's do a union. What is the size of the union of A and B? Yep, 15, very good. All right. You guys are good in this. Let's do one more. 15. And B is even numbers. Even integers. What is the size of the intersection of A and B? B is all even numbers. Why 15? 1 through 5, and then, wait, what was the other one? I forget now. We had before. What do we have for B before? I could rewind the stream. What do we have for B before? Was it 10 through 20 or 11 through 20? If it's 10 through 20, then there's 11 numbers in B, so it should be 16. Right. 1 to 5 and 10 to 20 is 16. Yeah. Not 15. Sorry. Off by 1 error. Very common. Right? Because there's 11 numbers in B. 10 to 20 is 11 numbers. 1 to 5 is 5 numbers. So how many numbers are in A intersect B? How many numbers are both in A and in B? Another way of putting that is how many even numbers are there between 1 and 15? 3, 4, 6, 8, 10, 12, 14. 7. And one person get that one right. Okay. Okay. How big is the union of A and B? The union. How many numbers appear either in A? Well, there's 15 here. How many numbers appear in B? That's an infinite set. So the union of these guys is going to be infinite. But, yeah, we can just write infinite, I guess. If you take discrete math, you'll learn to talk about that with a little bit more precision. Sure. Infinity plus 15. That's just infinity. So the size of that is infinite. Okay. Okay. What is the size of A union B now? $30. Good. All right. What is the size of A union B complement? Our universe here is Z. So our universe is all integers. What is the size of A union B complement? So all numbers that are either in A or not in B. The size. The size. What is the size of this set? $15? Well, there's definitely 15 people in A. But we've got to add in to this set that we're making everybody who's not in B. So -9, 70, 420, all of these are in the set that's produced. So how many integers are either in A or not in B? This is infinite. Right? It's how many numbers are not in B. There's an infinite number of them. Right? There's 30 people in B, so there's infinity minus 30, which you can't really do, in B complement. Okay? So, okay, what is A complement? Intersect B complement. How many numbers are both not in A and not in B? And if you hear me using like English for this, yeah, intersection is kind of like and, union is kind of like or, and complement is kind of like not. Right? So how many integers are both not in A and not in B? 0, 9,000, 420, negative 63. You don't say 31 minus infinite, just infinite. Okay. All right. Technically, it's something called Aleph null. You'll learn about that when you take discrete math. Okay. So I'll put up a little quiz for you guys on this so you can get a little practice with it. All right, so what we're going to talk about today is the three main types of reasoning. Okay, and these are deductive reasoning, x implies y, x, therefore y. X implies y, not y. Nope, that's a terrible y. Not y, therefore not x. Modus Ponens, Modus Tollens. We've talked about these extensively. This is called deductive reasoning, where you set up some sort of implication. You assert that x is true or that y is not true, and you can make a conclusion from that. Is Aleph null the smallest infinity? Yeah. Aleph null is the size of Z is Aleph null. Okay. What is the size of rationals? Rationals, what? Q. And it's also Aleph null. So if you take any integer and divide it by any other integer, right, is rational. It's the same number. There's actually the same number of integers as there are rationals. Here's a question. What is bigger? Are there more positive integers or integers? What do you guys think? Which one of these is bigger? Are there more positive integers or integers? Both positive and negative. What do you guys think? Twice as many? Wrong. Yeah, it's actually exactly the same size. There's actually exactly as many positive integers as there are integers. And if that hurts your brain, good, it should. 1 can be paired with 1, 2 can be paired with -1, 3 can be paired with 2, 4 can be paired with -2. Since you can create a one-to-one and onto mapping ... Because you can create a one-to-one and onto mapping between positive integers and all integers, they're actually exactly the same size. If you can create a one-to-one and onto mapping from one element of one set to one element of the other set, they're the same size. So it's a little preview of discrete math for you guys. Discrete math should hurt your brain repeatedly in a good way. Okay, so not positive and negative infinity, just both of these are Aleph null in size. Okay. So yeah, infinities are weird, and if you want to do a fun brain hurting activity, go onto Wikipedia and read about cleanly. Hilbert's Hotel. Okay. So go on to Wikipedia and read about this, and it'll kind of help you understand infinities and things like that. Okay. So deductive reasoning, for your capstone essay, you're going to have to write about any topic you want that we've covered in this class, and you're going to have to use all three styles of argumentation in the essay. And so using deductive reasoning is worth 5 points. Somewhere within your essay, you should, and I want you to actually highlight this and say deductive reasoning, bold it, so that when I grade it or the TA grades it, we can look at it and be like, all right, they used it. Okay? Make it easy on us to give you points. Okay, I don't want to have to hunt around to find it. Okay, so 5 points using deductive reasoning. You have to use an argument of this form or this form. All right. Second, inductive reasoning. And then third, abductive reasoning. This is 5 points. This is 5 points. And then peer review is going to be 5 points. Okay, so these are the topics we're going to talk about today. All right, so Hilbert's Hotel. Yeah. How long will the essay be? The essay has a requirement, a length requirement, given to you by the college, and also the college's coordinator. They actually have a person you have to submit the GE essay to. Let's see, did I add this on here? No. GE portfolio. Sure it's going to give you the points in the right category. So the there. Okay, so this is going to be due on May 3rd, so 2 Mondays from now, 10 a.m. It is due, and it has to be 1,000 words, which is about 4 pages. So it's not a page count; it's a word count. All right, and that's a requirement provided by the college. If you want help on it, or if you want me to read over the essay prior to you submitting it, you're welcome to send it to me on Discord, and I'll take a look. You have to submit it here, I believe, and you're also going to post it onto the Canvas so I can grade it. The GE portfolio thing isn't related to me at all. I don't see that. You just have to do that. Okay. So you're going to write this portfolio essay. You're going to submit it here. I have nothing to do with that. I am going to grade it by you pasting it on Canvas. Okay. So there's a bunch of topics you can talk about, and you are going to be graded based on using the 3 forms of argumentation on it, which again we're going to be talking about today: deductive reasoning, inductive reasoning, and abductive reasoning. And you need to tag it. Okay, so tag, put in bold, this is my deductive argument, something like that, so that we can look at it and make sure that you are actually doing the right form of reasoning and give you the points on it. And then you will do peer review also. If you do not turn your essay in on time, you will not get a peer review. And so, yeah, like every time we've done this, had students contact me, I wasn't given any students to peer review. And a lot of times because they didn't turn the essay in. So, okay, so we're going to talk today about inductive and abductive reasoning. Let me pull up the presentation on it. So with deductive reasoning, this is a logical argument. Like I said, either the two valid forms of logical argumentation, modus ponens or modus tollens, are A-OK for deductive reasoning. For example, squares are regular 2D polygons with 4 equal sides. Premise, I'm looking at a regular 2D polygon with 4 equal sides. I don't know, that kind of looks like a rectangle to me. No. Conclusion, I'm looking at a square. Okay. So generally speaking, if you have a general principle and you're arguing to a specific, that is deductive reasoning. So, does it look like a square to you? I don't know. I'd have to measure it. No, definitely not a square. That's a rectangle. Okay. Fooled you all again. So it's going to be like your past discussions, yes, except there's the added thing that you have to submit it to your portfolio so that the college gives you credit for this class, because you have to do a portfolio essay as part of your college graduation requirements. Do you need to find sources? Yeah, you should always cite your sources. You're not going to be graded on that, but in general, anytime you make an evidential claim, you should have a URL or something to paste that we can take a look at. What's this about a portfolio? Your college requires you to do a portfolio. Like a portfolio is like a bunch of work that you've done that you want to showcase. Do you know what GE section it goes to? It's where'd it go? All freshmen and transfer students admitted to Fresno State Fall 2018 and later will be required to submit assignments they complete for specific GE courses and reflections right outside of class to the digital GE program. You access it through Canvas. Everyone is added to a GE ePortfolio course, which should display in the dashboard with your other courses. The homepage of the ePortfolio course has information for students. So this one is the critical thinking one. Okay. So, deductive reasoning is a logical argument, and if the really nice thing about deductive reasoning is that it's very certain, right? So if the two premises are true and the form of the logic is valid, then the conclusion is true as well, and you know that with as much certainty as a person can have, right? There's always a chance you're having a stroke and aren't processing logic properly or something like that. But in general, if you look at an argument and the form of it's valid, you look at the premises and the premises are true, you kind of have to accept the conclusion. That's all there is to it. The only way that you can attack a deductive argument is by attacking either the form of the argument, pointing out, oh, you're doing affirming the whatever and denying the whatever, denying the antecedent and affirming the consequent. If they made a foolish mistake like that, and you can look at the form of it and be like, oh yeah, that's a fallacious form of argument, then that's one way of disposing of it. The only other way that you can attack a deductive argument is by looking at the premises, right? Or maybe they did some equivocation or something like that in there where, it looks like it's valid, but they're actually using the word here and the word here in a different way or something like that. But basically, the only real means you have of attacking a deductive argument is by going after the premises, right? And it's pretty hard to attack this one. Squares are regular 2D polygons with 4 equal sides. Yeah, it seems pretty correct to me. This premise, I'm looking at a regular 2D polygon with 4 equal sides. Yeah, you can attack it by, getting out a ruler and like measuring the supposed square. And be like, nope, it's not a square, it's a rectangle. So that's how you would do a counter argument. Nope, that is not a square, that is a rectangle. Okay, does not have 4 equal sides. Okay. Okay, most teachers aren't very good at communicating with their G assignments. Yeah, in this class, it's like pretty upfront. Like, this is your G assignment. It's 10% of your grade too, so make sure you do it. Like, there's a whole separate grade category in Canvas for doing this. So all the discussions we've been doing have been kind of leading up to this. I think normally we would have done probably like one more discussion, but either way. I wanted to give you plenty of time to work on this. All right, so if x and y, if y then x, then z, x, therefore z. Example 2, all mammals have hair, all cats are mammals, Toby is a cat, therefore Toby is hair. So these are a little more complicated deductive arguments, but they're still valid, and presumably Toby is a cat, so maybe sound as well. All right, Kearney, a real one. Thank you. On that note, if you enjoyed this class and wish to see more of it in the future, go do the course reviews on Fresno State. I don't know where those. Did you guys get that? Did you get like a link to the surveys? Have you guys seen that? Or do I have to post that? They're available now. Yeah. So you should be able to review the course. And remember, if you hate this course, my name is not Kearney. My name is Bob. Bob Junes. I could probably find a link for you guys. Did you guys get emailed out a survey link or something like that? It's on Canvas. Okay. Yeah. So, right. So, inductive reasoning. So, inductive reasoning is less certain than deductive reasoning, but it's the most common. So, deductive reasoning is very common in logic, right? Inductive reasoning is very common in science. So, inductive reasoning says, based on our experience with the past, make a prediction about the future, right? And these things are always, less certain, right? Because you'd be wrong. Right? So, sun came up yesterday, sun came up the day before, sun came up the day before that. Therefore, the sun will come up tomorrow, right? So, the sun will always rise, or the sun rises in the east and sets in the west, We've observed that every day of our lives. Therefore, I'm going to predict that tomorrow the sun will rise in the east and set in the west. And I'll take a $5 bet on any student that wants to argue otherwise. Because if it doesn't, we're probably all dead. Right? Like, if everything started spinning the wrong way in the solar system, we'd probably be super dead at that point. Okay, sun is just a simulation. Yeah, and that's a valid. Maybe not worry is the right word, but yeah, it's possible the sun's a simulation. It'll just somebody will enter a Skyrim cheat code and cause the sun to come up the other way. Yes, the teacher, not Kearney, made the class very fun. No. If you think it's fun, my name's Kearney. You got to get this straight, You hate the class, then my name's not Kearney. Okay. So my friend has picked me up on time from the airport before. Therefore, I have confidence he'll pick me up from the airport on time tomorrow. And so this is a true story, right? I used to fly from San Francisco to San Diego all the time for work, or drive it, which was annoying. To say the least. Doing that drive between San Francisco and San Diego a couple times a month was brutal, absolutely brutal. So I started flying. It was expensive, but my friends would pick me up from the airport. And so, one of my friends is pretty reliable, and And so I'd be confident that he'd pick me up, on time, every time I flew. Except once he didn't. And, so my inductive reasoning turned out to be wrong, right? You get a flat tire or something. Actually, I think he just forgot. But, like you could get a flat tire or you could forget or something like that. And so inductive reasoning is inherently less certain than deductive reasoning, right? Like, we use it all the time, right? Like, when my wife orders DoorDash, she typically orders food for me. So, I usually don't worry about food if she's ordering it, So, do you guys understand inductive reasoning? Like, just based on your experience of things in the past, you'll predict something similar will happen in the future. That makes sense? Uber Eats. Yeah. What was the yikes for Hernandez? Oh, the flights. Yeah. Flying wasn't too bad. Like, Southwest had cheap flights between San Jose and San Diego. It's like $75. Not too bad. It's like probably about how much you'd pay in gas, But the that drive. No thanks. All right. So this is there's a philosopher named Bertrand Russell. Some people consider him one of the fathers of computer science, along with Alan Turing. Mother of computer science might be Grace Hopper. It's a very famous woman who was an admiral in the Navy until she was like, I don't know, old. She was really old and still on active duty in the military. Required an act of the president every year to let her stay in the Navy on active service. Okay, so Bertrand Russell, father of computer science, said this. Imagine you're a turkey at a turkey farm. You like the farmer, he feeds you, gives you, takes care of you if you're sick, gives you shelter. And then one day you see a lot of turkeys going into a certain shed and none of them are coming out. You talk to your buddy and you're like, hey man, this looks suspicious to me. I think I'm going to make a break for it. And your buddy's like, hey, he's a good guy. Let's just go in. We can trust him so far. So do you see what the problem is? Is that your buddy's using inductive reasoning, saying, well, the farmer's always been good to us so far, we should go into that shed, And of course, you're going to get executed for being a Thanksgiving turkey. Okay? So this is a thing called the problem of induction. The problem of induction is that it's really hard to justify arguing inductively, right? Especially when it's something soft like this. Particle physics, electrons, as far as we know, behave the same way. All electrons behave the same as sort of a foundational thing in science, and the laws of physics don't seem to change, or if they haven't changed very much, right? Because we can observe galaxies from the past. Light arriving from 1 billion years ago is essentially carrying a record of what we can view what a galaxy looked like 1 billion years ago if it traveled 1 billion light years to get here. Physics seems to be pretty consistent. So, fighting a chicken. And so with physics, physicists will be like, yeah, sure. I mean, I guess laws of physics could change tomorrow, but they haven't so far. So, it works. But if you're working with people and things like that, like induction is a lot less certain, right? Like your friend picks you up every day from the airport on time, and then one day he doesn't. Right? So imagine you have a barrel of jelly beans that are 1 million lemon lime flavored and one that is booger flavored. These are like the Bernie Bott's beans, right? Have you guys ever had those? The Bernie Bott's, what are they called? Multi-flavored beans, or Every flavor beans, yeah. Yeah, and actually, I kind of figured out a way of flying for free. That was kind of interesting. What I'd always do is book myself on the busiest flights between San Diego and San Jose. And typically I'd book myself on a flight earlier than the flight I wanted to take. And then airlines oversell their flights, typically, if they can. They sell more seats on a plane than there are seats on a plane. And so if everybody shows up, the airline goes, oh, we will pay somebody to take a later flight. We'll give you a voucher for a free flight, let's say. And I put up my hand, I'm like, sure, I would like a voucher for a free flight. And so I would show up for like a 10 a.m. flight, be completely booked out. And they'd be like, all right, you're going to have to wait around for 2 hours for the next flight to San Jose. I'm like, all right, I can do that. And then I'd wait for 2 hours and get a free round trip ticket on Southwest. And then the next time I flew on Southwest, and oftentimes they'd throw in credits, like they'd throw in actual money. Like, we'll pay you $100 and give you a free flight. All right, sure, I'll take that. And then the next time I fly, I do the same thing. And with a flight down from San Jose and a flight up from San Diego, those are two opportunities for the flight to get booked out and for me to get a free travel voucher. So once I did that like 4 times in a row. Like, I was just like getting paid $100 a flight and getting a free flight on the next flight. Like 4 times in a row, I got that. And so I was just flying back and forth between San Diego and San Jose, essentially for free. Worked out really nice. Shepherd's pie, fish oil, custard, guava, peanut butter and jelly sandwich, spinach, celery, slime. Did they ever notice? What do you mean? I mean, that's, I was, no. I mean, why would they? It's not like I was doing anything wrong. They do this on purpose, right? And so I was flexible with my time, because it didn't really matter to me what day I flew up. So, or what time I flew up, as long as it was on the same day. So I would never book the last flight, because then I'd have to wait to the next day, But yeah, yeah, man, I was flying for free for a long time that way. It's really nice. Saved me a lot of money. Okay. Life hacks. Ethical life hacks. So if you are trying to eat these jelly beans and you keep eating them and eating them and eating them, you become more and more confident over time. Assume you keep eating lemon lime flavored Bernie Bott's beans, you're going to become more and more confident this is a barrel of lemon lime flavored beans. And you'd be wrong, right? Because one of those is booger flavored, right? And so this is how produce inspection works, right? If you get a bunch of lettuce into the country, the port inspectors will open up some random crates and take out some random fruit and test them to see if they have E. coli on them and stuff like that. But if like one of them has E. coli on it, they're not going to probably find it, right? You got a million tomatoes coming in, they'll test 100 of them. And from that testing, they're like, yeah, we're pretty confident this produce is safe, and they'll pass it through. And then somebody get E. coli and die, right? That's a real problem of induction. Don't worry about talking turkeys or whatever. Like, that's the actual problem, is that if you have a rare or unusual event, your inductive reasoning, which works well for reasoning from specific examples to a generality, is wrong. And people have died in the past because of that. So, inductive reasoning is basically arguing from specific examples to making a general principle. This is how science works. Science is the process of making observations of the world and then drawing a general conclusion from it. Right? I've observed ladybugs, and there are this many with 1 dot on their back, and this many with 2 dots, and this many with 3 dots. And so we are going to propose a rule that ladybugs have between 1 and 6 dots on their back always. And then someday somebody finds a 7-dot ladybug. You're like, my theory was wrong. I'd just never seen one before. Right? And so that's how science works. You look at individual cases and you make a rule. You have some broader rule. And then there's the gambler's fallacy, of course, right? So gamblers, I don't know if any of you guys are old enough to go to Vegas or whatever like that, or were old enough to go to Vegas prior to the pandemic, but people come up with all these really stupid rules in Vegas, or yeah, I guess you can do Indian gambling. Somebody's rolled like 3 sevens in a row, and somebody say, "Well, I'm gonna bet this way because there's no chance it'll be another 7 in a row." The dice are due, man. They're due. No, the dice don't have any memory. The dice have no memory whatsoever. If you flip a coin, you get heads 3 times in a row. That doesn't mean it's due to be tails. Like the human brain wants balance. We want if it's a 50-50 chance, we want the results to come out roughly 50-50. But this is called the gambler's fallacy. Flip it again, no, it'll be 50-50 chance. It'll be head or tails. If it comes up tails, they're like, see, man, I told you it was due. And if it comes up head again, they just kind of ignore it, confirmation bias. Okay, now it's really due for tails. And people make all sorts of idiotic bets that way because they think that these random processes have memory, So, roulette, it's got to be black. It's been red 4 times in a row. It's got to be black. Yeah. Okay, that's classic inductive reasoning, right? The bigger problem with this is that it undermines science, right? So the notion that the sun will always rise tomorrow is wrong, right? At some point, the sun's going to burn out or explode or engulf the earth or something like that. It's guaranteed to be wrong at some point, right? At some point, the sun will not rise tomorrow because there probably won't be an earth left at that point, right? And so, if you're it's one of those things, right? Like, it's a rule that's guaranteed to be wrong, but everybody believes it anyway. The sun will always rise tomorrow is wrong, right? Probably tomorrow it'll be right, but at some point it'll guarantee to be wrong. Okay, so let's not undermine science quite yet. We got a couple minutes left. Vegas is wild. Yeah, it's an interesting town. Most of Vegas isn't the Strip, right? The Vegas Strip is its own, like, enclave. If you're a person who lives in Vegas, like, it's a completely different world. Most of Vegas is just like suburbs out in the desert. No different than living in Fresno, except you have access to 24-hour food, which is really nice too. Like, you go to Spring Mountain Road. They have some really good Asian food on Spring Mountain Road, and a lot of them are open 24/7, so it's really cool. But just the number of dumb things people believe about gambling. There's a reason why they're able to have all that water in the desert. It's because there's dumb people with money. Right? Oh, that water doesn't get there for free. You know what I mean? All that power, all those fountains and pirate ships and things like that. None of that's free. All of that is money squeezed out of people who don't know math. Okay, so abductive reasoning is the third form of reasoning. Okay. Went to Vegas, felt weird going from an out of nowhere country boy and then going to a big bustling city like Vegas. Yeah, it's pretty unique, I would say, in America. It's a pretty unique city. Oh. Neighbors report hearing an argument between the couple living next door. There's a loud bang. Police are called. One person lies dead on the floor, shot. What happened? Right. And so you can't use deductive reasoning here. There's no logical argument you can really make. You can't really do inductive reasoning, although maybe the police would. Like in situations like this, it's usually domestic violence or something like that. But abductive reasoning means looking at the evidence and trying to figure out what happened, right? It's not guaranteed. It's just like you look at the evidence, you make a best guess about what happened based on the evidence, right? So, you start off, you're like, all right, probably it was a gunshot murder, something like that. And if one person's there and there's a gun and there's a person that's gunshot, they're probably going to arrest the other person, you know what I mean? And then figure it out later. Right, just in case it was murder, they don't want the person to get away. Right? But there's plenty of other scenarios that could have happened, right? Like the person could have shot themselves, right? Happens. The person who's dead could have tried murdering the first person, and there was a struggle, and the person defended themselves. And do you understand? Like, there's a lot of actually different scenarios that match the evidence, right? And the trouble is that humans will typically leap to some conclusion. It must be murder, and then that will color all of their investigation. We're gonna do this on the assumption that the second person murdered the first, and so they're gonna look for evidence to match that, and they're maybe gonna ignore evidence that doesn't match it. And that's why it's really important in criminal defense proceedings that the defense get access to all of the evidence, not just the evidence the prosecution wants to highlight. There's gunpowder residue on the survivor's hands, right, indicating that he or she fired the gun. Give us all the lab results, right, let the defense look at the evidence themselves, and then they can present evidence to the contrary to the jury. Right? And so, one of the things that really irks me about Sherlock Holmes is that have you ever seen the new BBC Sherlock Holmes show? You guys ever seen that show? It's on Netflix. It's really good. It's got Benedict Cumberbatch in it, and as like a socially awkward Sherlock Holmes. Really, really good series. Excellent series. The thing that bugs me though is that he and his brother Mycroft will play a game of deductions, and they like have a hat, and they like smell the hat, and they're like, oh, clearly this person is a coal worker, and he throws it to the other person. Well, this person lived for 7 years in a house on a top floor, and they do what they're calling deductions. That's not deductive reasoning. It's abductive reasoning. Abductive reasoning is when you look at the evidence and you make a best guess based on the evidence. Okay, they're not doing a logical deduction. They're not doing deductive reasoning. They're doing abductive. They're looking at, look, there's scratch marks next to the place where the key goes in on the front door. Clearly this person is a drunk because they couldn't get the key in the first time. So every time they came home drunk, they would scratch that's abductive reasoning. They don't actually know that. They're just making a best guess based on the evidence. Okay? There's plenty of other reasons why you could have scratches on the keyhole on your front door. For example, the person living there before you could have been a drunkard, right? Or maybe you're just coming home late at night and you can't see very well, and so you kind of a couple times until it goes in, right? Sherlock Holmes, Robert Down, that one wasn't nearly as good in my opinion. Although it does have the Rocky Road to Ireland in it, which is one of my favorite Irish pieces, Irish songs ever. The Rocky Road to Dublin, great song. Slip Jig. Tells a story about a man from Connacht, the northwestern region of Ireland, traveling to Dublin, searching for work. He gets robbed. He ends up traveling to Liverpool. People make fun of his accent. He gets into a fight. That's the story. So, but they call it deductive reasoning. No, abductive. Sherlock Holmes uses abductive reasoning. Thank you. The science of deduction. No, it's not. It's really not. Okay. So, yeah, we'll just stop there. So, so science is based on inductive reasoning, right? Because with science, what you do is you make a bunch of observations. You're like, all right, well, we'll make a model that explains all these observations, and this is subject to the problem of induction, right? Like, if you're a psych professor and you survey your guinea pigs, i.e., your college freshmen, because they mandate that college freshmen participate in a number of experiments in psych classes, right? And then you publish papers saying, premarital sex is huge in America right now. Like, it's like, is that true, or is it just true about college freshmen? And so you really have to be careful when drawing a general conclusion about Americans if your only population is college freshmen. Americans love drinking beer, do they? Or is it just people who are living away from home for the first time? Why do we trust science? Because it's been proven to be trustworthy. That's inductive reasoning also, right? And a bigger problem is there's something called pessimistic meta-induction. And so, where is the doubt everything guy? Let's for the essay, do we pick one topic for all the reasonings? Yes, you pick one topic and you write about it, and explain it, give your views on it. But at some point in the essay, you must use all three forms of reasoning: deductive, inductive, and abductive reasoning, and just tag it. Put in bold deductive reasoning. Like, I understand it's not going to flow very well, but just tag it so that when I or the TA read through it, we can be like, all right, they use that there and that there and that there. Oh, nope, that's not abductive reasoning. That's not deductive reasoning. -5, -5. Okay, that is inductive, 5 points. They did a peer review, 5 points. You get a 10 out of 20. Easy. Yep. So make sure you understand these three things prior to writing it. I could probably put up a quiz on it just to test you guys on it. But let me leave you with this. The doubt everything Hammond person. Can we talk about one fallacy and apply the three types of reasoning? Yeah, I guess. But I mean, I don't know how you squeeze 4 pages out of one fallacy. So, inductive reasoning. If we accept inductive reasoning, based on our past experience, we can draw conclusions for the future. That's the basis of science. Now, let's apply this to science itself. This is an argument called pessimistic meta-induction. If you look at what science has believed to be true in the past, almost all of it has been wrong. If you think about what we believed in the year 1899, what is electricity? How does physics work? Does light have inertia? All these kinds of things were all believed to be a certain way, and almost all of them are wrong. Therefore, 100 years in the future from now, everything we believe right now is going to be proven wrong as well. Therefore, we should believe nothing in science. So based on the reasoning we use to justify science, we should not believe science, because science has been wrong about nearly everything. Something like 80-90% of scientific facts that we believed 100 years ago are wrong today. Okay. So, therefore, by the reasoning that justifies science, inductive reasoning, science is proven to be untrustworthy. Therefore, we should not believe science. So this is an argument called pessimistic meta-induction. If you accept the reasoning that supports science, you can't support science. And if you don't support the reasoning that supports science, you can't support science. So therefore, we should not trust science. Right? If inductive reasoning is acceptable, science is unreliable. If inductive reasoning is unacceptable, then science is unreliable. Okay, so what do you think? What's the alternative? Not accepting science? That doesn't seem very smart either, right? You go through life saying, I'm just not going to believe in electricity. I'm just going to stick my finger in the socket right here. Right? That doesn't seem like a very good way of going through life either, right? So, yeah. So that's what I mean in philosophy. It's like, okay, that's a pretty good argument, But then the alternative is like, oh, it's a pretty good argument too. Like, we probably should trust science because it seems to be working pretty well. We got computers and GPS and stuff like that, and that's all based on quantum mechanics and stuff. And when will the assignment be unlocked? It should be unlocked. Should be unlocked. Okay. So with that said, I will leave you in doubt, and we'll pick it up on Monday. All right. Nothing makes sense. We live by theory and assumptions. I don't know. I don't have a good answer for you, right? Because it seems like both alternatives are just terrible. Either accepting contradiction or not believing science on anything. Both of those seem like a really horrible way of going through life. So with that, I will leave you in doubt. And I will see you guys on Monday. See you guys.